Hi students, in this video we're going to be going over equations and inequalities. Our essential question for today is, what is the difference between equations and inequalities? So what are the differences between equations and inequalities? So first, let's talk about what these are and specifically what are the definitions and some examples of equations and inequalities. Now, an equation is a statement that says two expressions are equal. So some examples of this include x equals 5. That's saying that whatever is over here on this left side is equal to whatever is over there on the right side. Okay? In the same way, 3x plus 4 equals 12. It's saying whatever is over here on this left side is equal to what's on the right side. So if I was trying to find out what the variable was, x, it would have to be a number that allows 3x plus 4 to equal 12. And another more advanced example would be x plus 5 equals 2x minus 10. This left side has to equal this right side. So whatever I find out x to be, it has to be the same on both sides. That way those two sides, those two expressions are equal to each other. Now a couple symbols you might see would be the equal sign and the does not equal sign. Okay, we're going to be going over both of these a little bit today, but we mostly spend time going over the equal to sign. But those are important symbols. Now, inequalities are a little bit different than equations. It's saying that two values or two expressions are not equal. So for instance, it might say something like x is greater than 5. So the left side doesn't necessarily equal to that right side. In fact, it's saying whatever is on the left side is going to be greater than 5. Another one might be x is less than 12. Okay, so that left side is now going to be less than that right side. You might see one like this where it says 2x plus 5 is greater than or equal to 10. And that's saying this left side must be greater, or since it has that line underneath, it can also be equal to 10. And in the same way, we've got one with less than, saying that this left side has to be less than or equal to 12. All right, so just in case you're not familiar or you don't remember these, here are the different symbols. Basically, if you see a line underneath the arrow, that's when you're talking about something that is less than or equal to or greater than or equal to. Whenever you do not see the line, you're just talking about something that is less than or greater than. All right, so let's try to identify equations and inequalities. So this says, Debbie has at most $60 to spend on clothes. She wants to buy a pair of jeans for $22 and spend the rest on t-shirts. Each t-shirt costs $8. Is this an example of an equation or an inequality? Now, when you go through, I would highly suggest make sure you kind of pick out those important words that will help you understand the problem. And one of the most important words is right here at the beginning. It says at most $60. It doesn't say she has $60. It says she's got at most $60, which means then that it could be $60, but it might also be less than $60. It just can't be more than $60. So this tells us that it's an inequality, because it's not saying that it's exactly equal to something. It's saying it could be, but it might also be less than that as well. All right, let's look at another one. A person can pay $6 for a membership to the art museum and then go to the museum for $1 per visit. For a member of the art museum, what is the total cost of 43 visits? Now in this case, it's saying what is the total cost of 43 visits. It's not saying less than 40 visits. It's not saying more than 40 visits. It's saying the total cost of exactly 43 visits. So when we ask ourselves the question, is this an example of an equation or an inequality? We know that it's going to be an equation because we're talking about an exact amount of something. All right, on these notes, you actually do not need to write these down in your foldable, but what you are going to do is answer the questions on Edpuzzle. So take a couple minutes and try to identify whether this is an equation or an inequality on both of these problems. All right, possible solutions. So let's talk about finding possible solutions in equations and inequalities. For the following equation, identify all possible solutions. And it says x equals 5. Now you actually, on this kind of problem, only end up with one single solution. Okay, the only possible answer is for it to be 5. Because if I put 4 in there, 4 does not equal 5. Or if I put 10 in there, 10 does not equal 5. The only thing that equals 5 is 5. So this problem is actually very simple because the only possible answer is 5. All right, what about one where it says x does not equal 5? Now this one's a little bit different. What is the only number that cannot be x? Well, that number is 5, which means that every number except for 5 is going to be a solution. So for instance, 3 is a solution because 3 does not equal 5. 2 is a solution because 2 does not equal 5. 6 is a solution because 6 does not equal 5, and so on and so forth. So in this case, there's actually an infinite number of solutions, but the only thing that is not a solution is going to be 5. All right, inequalities. For the following inequality, identify all possible solutions. So this one says x is less than 5. So since it does not have that line underneath it, it means it cannot be equal to. So that means that every number that is less than 5 is a solution, but 5 is not included. So you would start at 4 and you would go down 4, 3, 2, 1, 0, -1, and so on. All of those would be solutions because they're all less than 5. And one more, x is less than or equal to 5. So this is almost the exact same as the last problem. The only difference now is that you've got the line underneath that less than symbol, which means it's less than or equal to. So that means that every number less than 5 is a solution, but 5 is also a solution now as well because of that line that's underneath the less than. So again, you end up with an infinite number of solutions. All right, take a second and solve this problem. You are going to identify the number that is not a solution for these numbers. All right, now let's talk about graphing equations and inequalities on a number line. So this is a number line, and you're going to be given problems. In this case, it's an equation. It says x equals 0. And this is very simple because like we talked earlier with finding possible solutions, the only solution for this is 0. So we simply put a closed dot on top of the 0. And that's because the closed dot represents something that is equal to that number that it is on. Okay, so if it's a closed dot, it's saying 0 is a solution for x. Because if I put 0 into x, 0 does equal 0. All right, let's try another one. This one says x does not equal 0. So in this case, we do something a little bit different. We put an open dot down because an open dot says that it represents a number that is not equal to. It's kind of saying that because it's open, it's excluding something. However, that means all the solutions to the right could go into x. So for instance, if I put 1 into x, 1 does not equal 0, so that's true. If I put 2 into x's place, 2 does not equal 0, so that's true. And that goes on forever. In the same way, so does the left side. Okay, -1 does not equal 0, so that's a solution for x. -2 does not equal 0, so that's a solution. So you end up with an infinite number of solutions, but the only thing that is not a solution would be 0. All right, let's try x is less than or equal to 2. Now before, when we had the equal sign, we had a closed dot. In this same way, since there is that line underneath that represents that equal to part, we end up with a closed dot on 2, all because that line. Then you have to ask yourself, okay, which numbers are going to be solutions, the one to the right or the ones to the left? Well, if I plug 3 in, is 3 less than or equal to 2? Well, that doesn't work, does it? So that's not a solution. But let's take a number from the left side. 1 is less than or equal to 2, so that does make it a solution. 0 is less than or equal to 2, so that is also a solution. So we draw our arrow off to the left side because everything to the left of 2 is a solution. And that means a solution to the variable x. Now this one's a little bit different. There is not that equal sign anymore. So when we do not have that equal sign, we have an open dot. And that open dot's going to go on top of the 1. Okay, so start trying to plug in numbers and see which ones work. If I plug in 2, is 2 less than 1? No, and 3 is not going to be less than 1 either. But 0 is less than 1, and -1 would be less than 1. So all the numbers to the left would be a solution for x. All right, so take a second and try to write an equation or an inequality from the given graphs below. All right, last example is writing inequalities. So how are inequalities written from word problems? So it says, Annie bought 10 bars of chocolate at the store. I think it's really important when you go through these to write down, or if it's paper copy, underline important words. So bought 10 bars is very important. Her friend purchased less chocolate than her. Okay, write an inequality to represent the statement. So what we're kind of comparing to is her friend. Do we know what her friend has, how many candy bars she has? No, so since we don't know that, we use x as the variable to represent something that is unknown. But we know that her friend purchased less, and it didn't say less than or equal to or at most, anything like that. So we know that x, whatever her friend's amount of candy bars are, is less than Annie's. So it's very simple, it just becomes x is less than 10. Her friend has less than 10 candy bars. All right, let's look at one last example. Okay. It says Robert has at most 5 video games in his house. So let's underline some of those important words. It says at most. It means he can have 5 video games, okay? But he might also have less than that. So in this case, when we write that inequality, we know we're going to have that less than or equal to sign, okay? Because it's saying he can't have more than 5, but he could have 5. So we just write it as x is less than or equal to 5. Okay, because for instance, I could put 3 in there, and 3 is less than or equal to 5, and that still makes sense with this sentence. Okay, so the last thing you're going to do is you've got a couple more practice problems. You're going to answer those and put them into Edpuzzle, and then you're done. If you have any questions, let me know.